Hello everyone, myself Soumya and our batchmates are Agnita Pal, Gautam Karthikeyan and Pavya. Our topic is about cancer vision, breast cancer prediction with deep learning. Breast cancer is the second most dangerous cancer, the first being lung cancer. Breast cancer consists 11% of new cancer cases, approximately, out of which close to 24% are women. People visit an oncologist in case of any sign or symptom of cancer. Mammograms are used by the oncologist to diagnose and detect breast cancer. Magnetic resonance imaging of breast, ultrasound of X-ray of breast, tissue biopsy are used to examine whether the cancer is present or not. Minting means that tumor is not a cancerous. A benign tumor cell is worrisome unless it is pressing on nearby tissue. Knows our blood vessels cause damage. Doctor may need to remove burning tumor through surgery. We need to remove the benign tumor before it is becoming malignant. Benign tumor usually don't come back. Our once removed, but if they do, they return to the same place. Malignant means that the tumor is made of cancer cells. These cells can invade nearby tissue. Some cancer cells can move into the bloodstream or lymph node. After they can spread to other tissue within the body. If the breast cancer is confirmed, the doctor will assess the patient for sentinel node biopsy and it is done regularly, which help to detect cancerous cell is the lymph node. Then it is sent to examine for the prediction or not. Deep learning techniques are also used for classification of burning and malignant tumors. The earlier detection of pressure can enhance the prediction and survival rate of the patient. This will help the patient to take necessary treatment and the right time and to get rid of the breast cancer. This helps in reducing the mortality rate of women. For burning tumor, the patient can avoid unnecessary treatment. Data mining techniques when applied in the medical field can help in the prediction of the various outcomes, cost minimization and upgrade the healthcare value to rescue life of people. The process of classifying tumor can be done by machine learning and deep learning technique. Deep learning techniques are give better accuracy when data is complex and large compared to the machine learning algorithm. Research is being done in the area of various data sets on breast cancer. Our aim of the project is to categorize whether or not the breast most cancer is being or malignant and are expecting the recurrence on non-regress of malignant instead of instance after a certain period. To achieve this, we have used deep learning classification method to fit a function that can predict the secret class of new input. This is our data set and it contains 569 sample with the patient ID, radius mean, texture mean, parameter mean, area mean and so on. We are going to implement our module using this data set. First, we have implemented the CSV file, which is the data set which we get and saved it in the Google Drive. Thus, we read the data set using the path of the data set from the Google Drive and we are checking whether the file is the same data set which we get it by running the code. Thus, the data set is loaded. We are checking for the null data and there is no null data and the data we have in the excellent data set. Now I am going to see how the data is distributed and I am going to plot is using Seaborn library. Here we separated the data as M and B. M variants represent malignant and B represent the benign. Here it shows about 200 milligrams and above 350 is benign. Now we have converted the data into zeros and ones as they have to be in binary digit. Here we are going to use the label encoder. We are defining x and y where x is all the attributes, y is what we are going to predict, y is basically the diagonal column in the data frame, but extract only the values, which means that we are converting it into a number free array. Now I am going to print the unique values of y, which is nothing but the b and the m. We have encode the b and m into 0 and 1. For that we are using scikit-learn pre-processing, which is a label encoder method, and we instantiate label encoder and we are going to fit transform and y values. Now we completed the encoding. We have normalized the scale so that we have to normalize the skills so that we can get all the values in similar range. The values are seen between zeros and ones. Now we are splitting our data test for testing and training, where it is 25% for testing and 75% for training. From this 569 data set, 426 data is split for training and 143 data set is split for testing. Here we added activation functions and we define that using the sequential function, which make it easy to add layers. For this module, we are adding a dense layer with 16 until and where the input dimension equals to 30 and the activation function we have used is called a ReLU. The other layer is added is dense with one output and the activation equal to sigma. Once we have done with that, let's compile the model using binary cross entropy loss and the optimization. As Adam in first layer we are taking 16 and as 496 parameters and we are dropping out 16. The other layer we are taking output of 1 and as 17 parameters and activation is 1. Now we have got the total parameters are 113 and these parameters can trainable. Now are going to build model by training the model. The loss here, which is our category cross, centrify the value is 0.7 and the value should be decreasing for the upcoming epoch. Thus, the goal for the deep learning is to minimize the loss. Therefore, the loss value should be decreasing and the accuracy value should be increasing. And here, both the validation loss and the training loss are decreasing. And in the graph, the training accuracy and the validation accuracy is increasing. And now we are done with the testing and training of the model of the. We jump on to the prediction. By using Seaborn heat map, we can get a visualized data. The heat map is testing that out of 89, we got 87 correct and out of 54, we got 53 correct and in one wrong. By the way, the data which was given is correctly predicted and the accuracy is almost 98%, which is higher compared to the existing module. Thus, we conclude that deep learning models give accurate output. That output is predictable in terms of probability in deep learning using activation functions considering the available dataset. In the present world, we first analyze the stage of people affected by the cancer using the built model and helps in the early stage of prediction, which can be helpful for the doctors to acute the cancer and can save the people. It is also used to decrease the mortality rate of women. In future, the techniques may be implemented on dataset that consist of images. The system may also be integrated with an applications or websites. The accuracy of the model created by increase in order to get better prediction in recent searches. It says that the breast cancer is the most often found in women, but the men can do breast cancer too. About 1 out of every 100 breast cancer diagnosis in the United States in found men. So this model can also be developed for the prediction of breast cancer in men. Thank you.